Open source electronic platforms allow us inventors and tinkerers to build quickly, revise frequently, and explore widely. Serial print is a common method to help users understand and debug the code. However, it is hard for the users to link the variables to their output and to visualize and inspect their code. Let's say that I'm building a circuit that uses a potentiometer to control the NeoPixel strip, like this. After I finish assembling the circuit and coding, it seems like the strip doesn't quite turn on all the way. I think it might be something wrong with the potentiometer, or it's the way I calculated the length, or it might be something wrong with the brightness value. At this point, our serial monitor is a mess. It is so hard to tell which lock corresponds to which line when they update it so quickly. This is inline. We can print the values of the Arduino functions directly on the line of code. We can also highlight the line of code that is being executed with this toggle line marking button. The problem is in the if-else condition. I want to swap this potentiometer out with something a little bit more interactive, like this flex sensor. It seems like the range is a little bit different from the potentiometer. I can use the histogram functions of this extension to directly record and display the range of this bend sensor, so we can accurately map this value with these. Now that we see how we can display the value and visualize the flow of the code, let's look a bit more into other expressions that we can use to visualize and manipulate those values. First, let's use assert for analog read. When a value is true, a check mark is shown. Otherwise, a cross mark is shown. Then let's check when the brightness value is at the maximum using the is expression. Volt expression calculates the voltage from the analog read value. Min stores the minimum of the input into a variable, as well as max, which stores the maximum of the input into a variable. We can lock the values we want into a file with the name we specified, or logs.txt by default. Additionally, it is important to note that the commands can be changed using the pipe symbol. For example, I can filter the value between a range, lock them, and then graph them. We can save values as variables and print them all out on the same line, like so. And it's also possible to display multiple variables on a single graph. You can hover your cursor on the data points to see the exact value of your graph. Moreover, you can scroll your mouse to scale the x-axis, and even pause the graph to better inspect your value. We can count the number of times a line is executed, or its accumulated value with each execution. More advanced functions like map and filter allow you to modify your values. In conclusion, with inline, we can better link the value of Arduino functions to the code, visualize the flow of execution, and modify those values for a better understanding of the code. Inline is available now as an open source project on GitHub. Check out the paper for more detail.